Chapter 3, Section 5 is about linear combinations, and linear combinations deals a lot with lines, but only in terms of a real-life story problem or real-world math. So it's kind of the connection between real world and linear functions. So some of the properties are, the first one is we can only add or subtract, so there will be no multiplying or dividing between our variables, and there will always be two variables, so probably an x plus a y or an x minus a y, nothing like an x times a y. Okay, so adding or subtracting with two variables. And then there's a difference between discrete and continuous. Discrete means we're going to have integer numbers only, so 1, 2, 3, 4, 5, 6. And continuous means I could have a fraction in my answer, so I could have a half or a third or a fourth. So the different types of graphs will look different depending on what kind of numbers we can have and what makes sense with our story problem. So we will look at examples of both. So example A says William spent Saturday morning mowing lawns. He charged $10 for a small lawn and $20 for a large lawn. He earned $140. Write an equation representing how much of each type of lawn he mowed. Okay, so if I mowed 10 small lawns, I could say 10s plus 20 large lawns. Okay, I could earn $140. So $10 for my small lawns, $20 for my large lawns, and I made $140. Now this is going to be a discrete graph because I cannot mow half of a lawn or a third of a lawn. Now technically you could, but you would still not get that $20, that $10. So when we're talking about getting $10, you have to mow the entire lawn. So whole numbers, which equals discrete. So then the question says, if he mowed 4 large lawns, how many small lawns did he mow? So I'm going to have 10s plus 20 times 4, because now I know that number, equals 140. So that gives me 10s plus 80 equals 140. I could subtract 80 from each side to get 10s equals 60. So s equals 6 small lawns. Okay, hopefully pretty straightforward. Example B is talking about zucchini selling for 49 cents a pound and tomatoes selling for 59 cents a pound. And together, in total, you spent $5.99 on vegetables. So the equation here, we'll talk about my 0.49 ounces for my zucchinis plus 0.59 ounces for my tomatoes would equal $5.99. Okay, so Z and T are talking about the number of tomatoes, but because I'm talking about 49 cents for a pound or 59 cents equaling $5.99, this is going to be a continuous graph because we're going to have fractional answers here because it costs a fraction of a dollar to buy each kind. So the question says, if you bought 6 pounds of tomatoes, how many pounds of zucchini did you buy? So since I'm talking about tomatoes and I don't know zucchini, I'll go ahead and plug in my 6 for my T and then solve that out for Z. So 59 cents times 6, and then subtracted that over to my other side will give me 245. Divide, and I will get 5 pounds of zucchini. Okay, so one type of each so far. So let's go ahead and look at example C. So for professional hockey, a win is worth 2 points, a tie is worth 1, and a loss is worth 0. Early in the season, the team had 11 points. So go ahead and see if you can kind of figure out this equation before I say it. We want to talk about the relationship between the number of wins, the number of ties, the number of losses. So I hope you got yours. I got 2 points for a win, so I'll say 2W plus 1T equals 11. Now I did not include a 0 for the loss because I don't get any points, so I really don't care. Okay, now if we think about this, this is going to be a discrete graph because I can't win half of a game, okay, or I can't win a third of a tie, okay, something like that. So when I go to graph something like this, I need to graph only the options that are possible. So let's say I don't win any games. To get 11 points, that means that I tied 11. Well, let's say I won one game. That's 2 points, leaving me with 9 ties. Okay, well, I could have won 2 games. That's going to leave me with 7 ties. I could have won 3 games, leaving me with 5 ties. I could have won 4 games, leaving me with 3. Could have won 5 games, leaving me with 1. The next option would be 6, right? But 6 wins gives me 12 points, so that's no longer an option. So what you want to do is you want to start at your least amount of possibilities, increase by 1 each time, and get all the way to the top, because you are required to find each and every possibility. Okay, so now when we go to graph it, wins will go on the x-axis and ties will go on the y, and I'll go by 1. So 1, 2, 3, 4, 5. Make sure you're labeling and putting up a scale. And I'll go by 2s on the y-axis, so 2, 4, 6, 8, 10, 12. Okay, so make sure you're labeling and scaling appropriately. So I'll go ahead and look at 0, 11. 0, 11 is going to be up here. 1, 9, 2, 7, 3, 5, 4, 3, and 5, 1. Okay, do not connect those points. Okay, because a discrete graph means I can't have a fraction answer. Those 6 points are the only possible combinations that make that statement true. So those 6 points are the graph. Okay, that is how your graph must stay. Do not connect the points. Okay, those are your only options. So this is what a discrete graph looks like. Example D talks about Mikey in chemistry class. He's got a 30% sulfuric acid solution and a 60% sulfuric acid solution. He wants to mix them together, so he's got 12 ounces. Okay, so we're going to let X be the 30% and Y be the 60%. So my equation will say 0.30X plus 0.60Y equals the 12 total. Okay, so I've got 30% plus 60% is going to equal my 12 that I have total. Okay, example A then says, okay, let's say he only wants to have 2.6. I'm sorry, example B says, now let's say he only has 2.6. So if I wanted to change my equation, I would keep everything the same, but then I would go ahead and just change my total to 2.6. Okay, so now that was example B. Let's go ahead and graph this first. Okay, so graphing this, I want to know, okay, is this discrete or continuous? Well, hopefully you realize this is going to be a continuous graph because you can graph or you can pour a 1/2 ounce of acid. Okay, so you want to make sure that this is continuous. So if it's continuous, I need to draw a line. Now, the easiest points to find on the graph, okay, are the intercepts. And we should be very good at this because we talked about this a couple days ago. So I'm going to go ahead and say, okay, if I let x equals 0, I will then have 4 1/3 for y. And then if I let y equal 0, I will have 8 2/3 for the x. Okay, so again, just make that xy table that you guys are really good at. Plug in 0 for x, solve for y, and then vice versa. Okay, so again, I'll label my graph. I'll put 30% on the x, and I'll put 60% on the y. And I will go by ones. 1, 2, 3, 4, 5, 6, 7, 8, and I'll go by ones on the y as well. 1, 2, 3, 4, 5, 6, 7, 8. So if I want to graph the point 0, 4 1/3, I can graph that up there. And 8 2/3 would be down here on the x-axis. So I have 2 points, okay, but this is a continuous graph because I can have a 1/2 or 1/3 of an ounce. So what I'm going to do is I'm going to connect them and actually make a line, so continuous line. However, I am not going to draw arrows and make it go beyond there because I can't pour a negative number of ounces, and over here would be negative, and over here would be negative. Okay, so you are not going to draw arrows. Your dots have to be on the x and y axis and it has to stop. Okay, so it's a continuous graph in the first quadrant that does not move on. Okay, so make sure that you are being very careful when you graph these. Okay. So if we take, excuse me, a look at example C, it says rewrite in slope-intercept form. Well, slope-intercept form is a y equals, so I'll move my 0.3x to the other side. So a 0.6y equals negative 0.3x plus 2.6, and then I would just divide everything by 0.6, so I can get y by itself. So I'd have y equals negative 1/2 x plus 4 1/3. If you had improper fractions, that's okay. So then letter D says, what does the y-intercept represent? Well, here's my y-intercept of 4 1/3, and that would represent if there was 0 ounces of my 30%, then I would have 4 1/3 of the 60%. Okay, so talking about what that actually means in relation to the problem is also important. So when there was 0% of the 30, there'd be 4 1/3 ounces of the 60. Okay, so that is an example of how to graph continuous. So we've taken a look at both, so we should be all set to go here on linear combinations.